Hello everyone, I'm back. I was talking about the crossbow modes. Crossbow Mika 2 modes, which is a representative of a wireless sensor network platform. It's fairly small modes, which is less than 16 cubic feet centimeter. It does have comes with multiple sensors such as acceleration and magnetic field. It also detects sound, light, and temperature, and so on. And it has a low bandwidth radio transceiver. It's up to 80-meter range. If it's shorter, it uses less battery, but typically 80-meter range is, considered to be pretty long. And it uses a 2 AA battery. It probably lasts for a month. If you use extensively, it can be, it'll last for only 20 days. And the storage is somewhat limited in 4 kilobytes, and which is very, very small compared to what you have. We're talking about gigabytes. This one is only 4 kilobits, and 512 kilobits for permanent storage, which it cannot be stored much at all. As you can see, that's why we're talking about tiny OS is needed, because so limited in memory and hardware storage space. It can do little things compared to our normal operating systems like Apple and Windows. When you typically compares 1981 PC compared to Mocha modes 2005, this is a fairly long time ago. And I just want to note that the Mocha mode does not exist anymore. It became obsolete. And a lot of the current devices using for research and developments are Arduino, Raspberry Pi, and there are a number of IoT devices. Here are the different frequencies: 4.77 megahertz, 4 megahertz, and as you can see, it's fairly comparable compared to 1981 and 2005, right? So those are the big differences. And you can compare your Android or iOS devices compared to 90s, 60s computer, which is full of computers in one room. Your Android is probably faster than what they had in 1960s. And the programming interface board made 510. This is Mocha 2, Mocha Z, Mocha dots. And basically, here's the dots available. It's like a coin device. You can plug in here. You can plug in any adaptable device to this interface here. And also, here's the IRS-232 serial port. This was a long time ago. And here's the Mocha 2 multi-sensor module, which comes with the light temperature microphone. And all of this became obsolete, okay? So this is one of the first IoT devices used for research and development. And here's the hardware setup as well, okay? And I would like to talk to you about a little bit of different application of the sensors. So first of all, is water monitoring, battlefield operations, forest fire detections, and environment and habit monitoring, infrastructure security, and industrial sensing, and medical application. First of all, border monitoring. This currently being used at the US-Mexico border. It ranges about 3,100 kilometers. It's a full length, which is for surveillance, basically detecting any movement using sensors. It could be animal, or it could be human, or any movement in that area. It can detect also sound or vibration within a 10 meter. Typically, what they do is they drop about 440,000 sensor from the air just dropped biannual every 6 months. And soon as you drop lands on the ground, and those sensors communicate with one another and start detecting any movement or sound or vibration. If it's detected, any of those informations relate back to the collector. It collects all the information. So as you can see, is biannually. After 6 months, when batteries used up, it's basically it disintegrate into the environment. It does not impact any issues for the environment. It's not cost effective because you got to do this every 6 months, right? And the typical is it's not able to detect whether it's a human or wild animal, and a lot of fault detection, which cannot be very effective, right? So here's the typical map here. As you can see, here's all the border, and currently we're having a lot of border, migrant issues, not just from the Mexico, Colombia, and other places, and that's becoming pretty, critical problem at this time. Another application is a battlefield surveillance, basically observing enemy activities in the battlefield. This is utilizing UAV to, as you can see, we probably heard from the Ukraine wars and dropping bomb from the UAV. This is one of the main activities. Observe any of the enemy activities using cameras on UAV. And the problem is it has a very limited radio range. It has to be fairly close, right? Another thing is if it's too long, radio is not reachable, it's not able to control the UAV, that becomes a problem. So, UAV is one of the devices being used to monitor the enemy activity. Compared to sensor nodes, so you need about 10,000 nodes required to just a 1 square kilometer. That's a lot of sensors. As you can see, there's some trade-off whether you're using UAV or sensor node. It's up to the missions. It's up to the requirements and a number of different things making that decision. But a lot of it is based upon cost as well. So typically what happens is a number of nodes communicating one another detects enemy activity, and those nodes will be able to send it to the UAV. And the UAV also has a camera to detect enemy activities as well. Another sensor is node is used for early warning system for forest. This is now randomly displaced in a lot of different territory. This is very carefully selected and placing the node where there's vulnerable to forest fire. And they try to reduce the number of the sensors required to cover the large graphical area, but there's always the trade-off, right? So a lot of cases in doing research, they try to place the sensor where they have what do you call that? A lot of fire activity in the area. Okay. The important aspect is lifetime. Typically, they use a solar panel to charge the battery for the sensor. They try to make it more of the lifetime. The problem is a lot of the birds, animal, sometimes interfere with the devices, and it can cause us damage and inoperable sometimes. Okay. Okay. Another application of the sensor. Okay, I have one more slide regarding to fire detection here. It's subject to random failure, and one of the reason is the battery exhaustion. Another thing is disorientation of antenna. It could be the wind, or it could be the bird or animal, could it, rearrange the antenna, and that could be an issue. Another interesting, research has been done is the behavior of the animals. Here's a monitoring the behavior of the bird, monitoring the blast. This is one of the research that has been done long time ago, and there's a sensors in the base of the bird and be able to watch and detect any of the behaviors happening down there. Another interesting thing is migration pattern of the zebra. They generally move around the wide area, and this study requires a long-term observation. What they do is that they have placed the ring around the zebra's neck, and detect the behavior using the GPS. There's a long range and short range. Short range for the neighbor, long range for the base station. They're used to monitor a number of different things, especially heartbeats, body temperature, and the frequency of the feeding. Basically, they evaluate the animals 4 seasons throughout the year, study the behavior. There was another application, it's infrastructure security, detecting any of the chemical, biological, nuclear threats, protection of power plant and the communication center. And this is becoming a very critical in this country. Relying on sensor is a must. For example, a network of video, acoustics, other sensors that deploy around the facility is very, very important. When you compare it to a fixed sensor, ad hoc sensor can be provided with more flexibility and provides additional coverage as well. Okay, so I guess coverage, it depends on how many sensors being deployed to reduce the false alarm. This is a typical picture of the infrastructure security. Okay, and there's an industrial sensing. This is pretty popular, low cost, improve the performance and maintainability. Continues to monitor the vibration, lubrication level. Sensor into the region is any accessed by human. They try to figure out proactively if there's anything wrong with it. They wanted to figure out before anything goes wrong. Okay. Now here's a medical application, heart rate, oxygen saturation, enhance emergency medical care, and things like that. And you see that, now you see it on the iWatch, measuring heartbeats, temperature, your EKG even for the medical application. Okay, so those are the different application of the basic foundation of the sensor. Hopefully this video really helped your understanding, and thanks for listening.